Today we are going to use x-intercepts to write equations when the vertex is unknown. So yesterday we used the vertex and a point, right? So what do you do if you don't have vertex? So there's just like a very similar process, just like a different step one. So you guys have probably seen your teachers have these stickers on their boards. Anybody seen this yet today? When's up if you've seen it? A couple of you? These essential question and agenda. Eric got to see me yesterday and told us about that. Anyway, today we're going, like whenever I write a standard, you can convert that to a type of question. So can we write quadratic equations given limited data? So yesterday our data was a vertex and a point. I think today we'll have intercepts and a point, and we'll write equations. And then just generally the agenda for this class is follower, check assignment, student notes, and group work, and then we do an independent assignment. Typically what we do regularly. Try to stay consistent. Hopefully not boring, but it is that. Alright, so the A through C graphs for your identifying x-intercepts are here. So here's graph A. Yeah. Try to identify the x-intercept. Here's graph B. And here's graph C. And then number 3 is important. Write a statement about what all x-intercepts have in common. Like any x-intercept ever. Good question. You have your statement ready? Okay, let's wait just a minute.
Like any x-intercept?
Yeah, there's something that all x-intercepts, regardless, have in common. Regardless of the type of graph. Well, no, we already gone through. So let's wait till somebody writes their intercepts down. Let's do that. We'll go from there. Okay. Letter A. A has 2 x-intercepts. Here and here. Can you see them all the way over there, Jerome?
It's negative 5 and negative 1.
That's true. Our x-intercept is this value here and this value here. So they're, and I'm going to write it as points. Negative 5, 0. Negative 1, 0. Alright, somebody else. William, what's the x-intercept on letter B? 2. And I'm going to write it as an ordered pair. 2, 0. Carter, what are the intercepts on letter C? Negative 2, 0. And 3, 0. Fine. But as far as the statement goes, the point kind of helps. You could read my mind. So, Aiden, what statement were you going to make? What do you think all x-intercepts have in common?
When you have an equation f of x equals 0, the x-intercepts are the x values of that equation when you solve for x.
Okay, good. Very beautiful definition. Let's add to it. Let's contribute to it, Sophia. Yes, I like that statement as well. So, Aiden, you kind of gave a definition of x-intercepts. Really good. The statement I'm going to write here is similar to what Sophia said. What do they all have in common? I'm going to go with all x-intercepts are on the x-axis, and that's fine. This is what's important. And have y values of 0. So that's why I went out of my way to write the points. because when you're on the x-axis, your y value is 0. You see all the zeros I wrote in those points? So if you know if the y value is 0, you are looking at an x-intercept. I want to point out that a quadratic equation can have, well, several different types of x-intercepts. Normally we talk a lot about y-intercepts, but with parabolas, we're shifting towards talking about x-intercepts. This parabola has 2. This parabola only has 1. Some parabolas have 0 x-intercepts. I'll show you. If your parabola looked like this, and it turned before it hit the x-axis, or like this, it never gets up there, no x-intercepts at all. These will, later in the chapter, we'll call these things no solution equations when they don't have x-intercepts. They're kind of floating in the air. So sometimes there's 2, sometimes there's 1, and sometimes there's none. So you know. So any questions before we check yesterday's work? It's math. Let's hear it. This one is called a hyperbola. So it has the same ending, but it's this one here is really Oh, let's check the assignment. Let's look at how that worked. Did I get to number 10 yesterday in third period?
You had like 20 minutes left on basketball.
Oh, sorry. I really thought I had more time than I ever do, so that's my bad. I'm really sorry about that. That doesn't usually happen to me. I'm usually like really like work. So I'm sorry about that. Not cool. Not cool. Though it is really important to wake people up and talk about real life math. That wasn't important. That was a waste of time. Get it together, Baldwin. Shoot. Okay, so did I begin number 10 yesterday? Yes. Okay, let's take a look at it.
We found that
A was negative 1/3. Everybody thumbs up if number 10. We're all together with A is negative 1/3. That is part 1. Part 2 is a little bit more challenging, so let's pause and look at it. So you repeat the whole process. It's kind of like you start over again. You start with the vertex form model, but this time you plug in the H and the K spot, and you plug in the A spot. So over here, I have the 1 and the 9, and I put in that negative 1/3 that we worked to find in step 3. This is the part that everybody's confused about right here. This x minus 1 squared. Do you remember how to do that? Yeah, let's think about it. Let's all think about it for a minute. Let me do it right here. Let me write our statement. Because we all need to be able to do this if we're going to move forward today. This is kind of everything. So if I have to do x minus 1 squared and simplify it, I write it out twice. This is called a binomial squared. I do x minus 1 times x minus 1. And I have to distribute. So it's called double distribution. What I'll do is I'll hide the minus 1. I have to distribute the x and the minus 1. Spoil. So here I would do x times x and get x squared. I would do x times negative 1 and get negative 1x, right? And then I do it again, but I cover up the x. Then I distribute the number next to it, the minus 1. So So negative 1 times x and negative 1 times negative 1. In the middle, you combine like terms, and that's where x squared minus 2x plus 1 comes from. I think once you get that down, finishing the problem won't be too much. All right, so after that, you distribute the 1/3, not all the way to the 9. Everybody forgets the 9 at the end. The 9 is here, still here. Distribute 1/3, and then you have to combine the numbers at the end. So I actually want to see everybody pull out a calculator right now. I've decided I'm going to give you 5 points in focus just for bringing a calculator. I think I know who it was. It doesn't have to be right now. Yeah, I didn't announce it. Okay. So here's what I'm going to do. I'm going to make like an open-ended column in focus for bringing a calculator to class. So when you bring your calculator, let me know to give you your 5 points.
If nobody plays that might be my calculator because I have the same exact.
Oh, you had this type?
You don't remember when you was like, what you have, and then I was like, my calculator.
No, I don't remember that.
But I don't know.
Oh, I remember.
Yeah, because I was open.
How'd you work when you get a permanent marker and put your name on your calculator? Since we work bell to bell, sometimes you have to click and leave and you forget it.
Yeah, this is definitely my calculator because the paper has it.
There we go. All right, so this is what I want you to combine like terms. Negative 1/3 plus 9. It turns out to be 26/3. And if you don't like fractions, use a calculator. If you're doing fine and you wish you were a little challenged, well then don't use a calculator. Do your fraction work mentally. 27/3 minus 1/3 is 26/3. Anyway, how am I going to do this? Two promises for calculator. What's your last name? What's your last name? Johnson. Okay, any questions on 10? Yes? No. No. You do that in the beginning and then you don't do it again. Well, you're taking limited information. You're using this formula. So right through. And then you're ending in standard form equation. So you're going from limited information to a full equation. This is like just a little bit of information, and then this is like everything. You know, you're making it everything. You may take a picture of this if you put your phone away immediately. There will also be a video posted in Schoology. What's funny about it? Here. Sure, yeah. Let me scroll to number 4. Oh no, I don't need to scroll. Number 3 was our next one. Here's some work for number 3. Listen. Well, it doesn't have any fractions at least. So really get into number 3 if you haven't tried it yet. See where you got stuff. This is the work for 3. And I will put up the work for 4. No, 9. I meant 9. Oh, here's the answer for 9. So I got 3 here, 9 here. You know what? I didn't walk around in first period. Today since I'm on the same page, I'm gonna grab up some tomorrow. We're not looking at second.
Hey, Gerard. Gerard.
Isn't the Y 10?
When I was little, I thought my best bleach was oh, 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 yeah, that's it. Hey, you said drugs. You like
Yeah.
it?
Yeah, let me answer your question and then I'll come back. Either of you two have a question.
You like little whiskey?
Has anyone tried to check one out yet other than that thing?
We did.
Did I tell you guys about the media centers?
What
Third
about it?
period?
What about it?
Okay, so there are some calculators in the media center to check out. The ACE Math 1 students get priority. But now that it's been over a month, if they have any left, they'll give them to you guys. So you check it out with your ID. You turn it in May. You get to keep it all year. You have to take care of it and return it. So if you still don't have a calculator, you want to try going to the media center and checking whatnot, you can. No, sometime. I will come right.
But if the school related, teacher will let you video cast. It just has to be like school related. Depending on the teacher, yeah. Some of them be green, bro. What is he? Oh no, I got Miss Hoover. She on the other side. He sells Snap. That's crazy. Another whole class. Another whole class. Hey, you should buy me one, bro. Hey, you guys here? Nobody be here tomorrow, bro. An essay? Bro. Coach PZ looking at it. Oh, God. For real, bro. But Miss Hoover, she just gives me worksheets and stuff. It's easy. And then she literally leaves her notes on the test. But she cool, bro. Yeah, she just talked a lot. She's talking a
Let's
lot.
not. Okay, let's not. Hey, if you have these done in your whatever, we're gonna do number 6 all together fresh. No one has even tried 6 yet. Let me make sure. Yep, we're gonna do 6 all together. On this one, it's at this ceramic one, so this is HCAT. So you're gonna write the vertex comma down, and then you're gonna write.
What? Maybe if you don't come mistakes.
saying, because I need my it's not bad, but it's not.
I'm one straight.
I'm gonna actually try this year. Last year, I went up, I didn't have a backpack.
Who had a question? You did.
Last year, bro, the last 3 months, I ain't bring a book back. But
It was way more exciting.
it was better. It was better.
I'm kind of used to it. But last year, bro,
Any other one? So you can make it.
she got love. She got love.
That happens a lot. That is extremely common. Sibling stealing calculators and it says Rio, I just said it worse. It says Alright, who's got a question on 3 or 9? Now that we've looked at 1 and 10.
We never got one.
We didn't look at 1 yet? Let's look at 1.
Look,
Is this one?
Unless you want to do it with us.
Yeah, I'm gonna do it with you.
Oh, never mind.
Oh no, here it is. I am gonna do 6 with you from scratch, fresh, like blank slate. Yeah. Here's number 1. So, if you were going through the process, so you know 1 negative 16 is the vertex, and I know that because of the 12s on either side. The one in the middle of the repeat. So I plugged in 1 and negative 16, and then I picked this first number, first point as the xy. So I plugged in 0 and negative 3, did all the math, got a equals 1. Any questions on how to get a? That's steps 1 through 3. So, are you successful in plugging in the h and the k? So the next step is to put numbers in here. The numbers in here are the first numbers. This negative 3 goes in the x spot, and this 0 goes in the y spot. And from there, it's just, you know, do this subtraction, square it, move everything over, solve for a. That's the math after that. So once you get everything plugged in, I think you can move through the problem. Yeah. It represents if there is a stretch or shrink in that parabola.
Oh, so it's still does the same thing.
Yeah, A is always A. There isn't one. So that's a whole different thing.
Oh, that's for today.
Alright, and then you start over again after you find A. Start over all over again. You go back to vertex form, but this time you do your H and your K. You plug in A, and you keep X, Y, X, Y. You just keep X, Y, X, Y. The second time through, you don't plug in the X, Y.
you only plug in the vertex.
Yeah. And then the A that we just found. So it's really just like a kind of elaborate substitution problem that you do twice. So it's 2 steps. And then you end up with the whole equation. It's actually pretty magical. Starting with a little bit of data, get a whole quadratic from it. Thanks to substitution. Yeah, it's x minus h.
So,
Alright, let's try number 6 now. Fresh start. No one, I wasn't assigned yesterday, so let's do number 6. Here we go. Okay, so when I look at number 6, I see the h and the k is provided. 2 is h and negative 6 is k. Grading? Ready, do number 6 right now. See here, full answer out. This will be, if you did all the assignment yesterday, this will be your 5th time doing it. I bet you start to really remember the process. Alright, this one is going to be the x and the y. Alright, we're going to start with a times x minus h squared plus k. This is the vertex form model. And I'm using that model because I have been given a vertex. So I'm going to plug in hk. What do we do next? Plug in xy. And no, this is an awesome thing. You only have one letter. When you only have one letter, that means you can solve for it. Only one variable. We'll be able to find that. Go ahead and find it. Find it before me.
Miss, so when that's so then the parentheses, when we find it, it would just add it to A.
It's multiplication.
So it would be 9.
Yes.
Yeah.
3 equals a times 3 squared minus 6. Add 6 to the other side. 9 equals a times 9. Divide. Good job, y'all. A equals 1. Check. That's half the problem. Start all over again. Do the whole thing again. So we use substitution to find a. Well done. Now we're gonna plug in again, but this time we're gonna leave x and y. This right here, so getting a, that's half the problem. Going to this next step is 3/4 of the problem. You're 75% credit now. And then students are telling me they're not really so confident from here. This is, I think, where students are like, oh, I'm just not confident in that. So I'm going to do x minus 2 times x minus 2. I have to do double distribution or FOIL method. Like I'm going to x on it, yeah. Yeah, we're trying to put it in standard form, so we're trying to work it all out. You finish this one? Okay. All right, so that would be x squared minus 2x minus 2x plus 4. X squared minus 4x plus 4. And so that 1 is still out front, and that minus 6 is still at the end. Everybody forgets the minus 6. They think they're done here. So many people circle this as a final answer. But there's more to the problem. This was just a little middle bit. So I would distribute the 1, which actually doesn't change anything this time because it's 1. And then combine the like terms at the end. And there we are. Alex, did you finish it? You finished it? Okay. There's a clue in my answer that tells me if I got it done right. p-value. Can you tell me the c-value here?
Minus two.
-2. Where should c show up on a graph? Your y-intercept. So let me consult the graph. Look at that. A y-intercept of -2. And my math resulted in a -2. That's kind of a cool check. It's all coming together. Very comprehensive. All right. So today is a very similar process, but we're going to start with a different step one. Let's take a look at example 2. Everybody flip your page backwards to example 2. If you have a highlighter, get a highlighter out.
Okay.
143. So I'm not giving you notes to write. Oh no, it's 142. I'm not giving you step-by-step notes on this. I'm referring you to the textbook example. I want to encourage you to refer to your examples. So that's what we're doing here. Yep. This one, and if you want to fold over the page, so you remember this was an important example and highlight it. Very similar question. It's writing a quadratic function. But this time it says using intercepts. So you're not getting told what the vertex is anymore. So if you're using intercepts and not the vertex, this is not helpful. Vertex form is helpful when you have a vertex. If you don't have a vertex, that's not helpful. Instead, we're going to start with what's called intercept form. And this is our first time using intercept form. Though you did write it down on Monday about work. You wrote down 3 forms on Monday: standard form, vertex form, and intercept form. And this is our first time looking at intercept form. This p-value and this q-value are x-intercepts. So this is why in that work I had you focusing on x-intercepts so you were ready for this. So when we look at our graph here, you can see the x-intercepts. I would call p -6 and I would call q 2. -6 and 2, p and q. These numbers get plugged into intercept form. Just like we plugged hk in, this time it's pq.
Does it matter which one is which?
No, doesn't matter. You can switch them. This one could be called q, this one could be called p, it doesn't matter. So you substitute this time in for p and q instead of h and k. And then you use the other point. So you'll have to be given some other rando point. And so this is x and y. You'll plug in that other point. X shows up twice in this form, so you plug it in 2 spots. And you plug in the y. So we have -4 here and the y here. And then you do the math again to find a. So it's the same first 3 steps. You're just starting with a different form. You find a, plug it back into the form. Still have to use the FOIL method, and you end in standard form. Similar. So after you've had a chance to highlight and read through this, I'm going to do your first assignment question with you, number 4. So go back to 147 and we'll do 4. Dang, that's 7 minutes in there.
No matter.
Hey, number 4, here we go. Today's assignment is 4, 5, 8, and 11.
Will they all be the same?
No, sometimes they're gonna give you a table. Sometimes they're gonna give you a
No,
graph.
someone like
Are we
steps.
talking all these
Intercept
ones?
one.
Okay.
Yeah. What's that?
Are we talking all these ones?
Yeah, this time we're all doing P and Q.
Why will they only work for P?
Well, you don't know the vertex here. I mean, I could find it because I know a lot about patterns. I could figure it out.
So
But what I have here is 2 zeros, which means I have intercepts.
no, those are the
This is P, and this is Q. Well, let's focus on the process here. Oh, my bad. So I don't have a middle point anymore. Well, we see the repetition, we see the symmetry. We don't know exactly what's in the center here. So anyhow, we call these P and Q because they have zeros. The key is that the zeros are there, and all x-intercepts have zeros. So we know those are x-intercepts. So I head to intercept form. And I put in x minus 6 and x minus 8. And then, you guys, I know I've been saying I'm going to use this as your xy, but since they're both 4s, let's use 10 and 4 as our xy point here. We're going to put 10 in for x and 4 in for y. And so x goes in 2 places. And now we've done it. We only have one letter left. Do your math, your PEMDAS, everything you already know, and find A. It looks just like a Y, doesn't it? Yeah, I went from Y to 4, but they look really similar. Maybe I'll really emphasize. Look at that. That's better. Look at that 4. Okay, so that would be 4 equals A times 4 times 2. 4 equals A times 8. Divide. And we figured it out. Aiden, do you know the vertex of this? Alright, so I got my 1/2. Who's got a question right now about how we came to 1/2 A? Alright, I'm going to start over. We got to do it again. Because our end game is to have a standard form equation. It doesn't say find A. It says write an equation. You have to know A to write the equation. So I'm going to start over. And this time, I only use P, Q, A. I don't use X, Y. Oh, so it's just a little bit under. And then, oh, 7 makes perfect sense. And then, oh, and A is 1/2. So is it negative 0.5? Alright, here we go. So I got y equals 1/2 x minus 6, x minus 8, 75% for getting this far. 75. 3 out of 4 points. Good job. This is very good. But we want you to end in standard form. So go ahead and do all the distribution and simplify this. I'm going to do x. Yeah, both methods you have to do that.
So, okay.
I mean, there's different. I use both modes. I'll just keep on the basic mode for now. Alright, so I'm at y equals 1/2 minus 7x plus 24. I want to remind you of one way to FOIL that might help you remember. A minus sign here. Yeah, that's a 4. Well, because it's 6 times 8, right? 48. Okay, if you're struggling with the distribution, when you do x minus 6 times x minus 8, did I show third period this window method yesterday? This was brand new in your textbook 2 years ago. We started showing you this in Algebra 1. You would do x minus 6 and x minus 8 up top, like a Punnett square in biology. And students like really like it. So I do x times x and get x squared. X times negative 8, negative 8x. That's negative 6x, and those two make a positive 48. So you can, if you're having a hard time with that FOILing or double distribution, you can use this method. That'll give you that. But if you just do enough, you start to come up with it kind of mentally. All right, so you guys have 5, 8, and 11. So you have 2 odd problems here at time. So you can check your answer. I am available after school today as well. If there's anything that you need to come in and get done. We got some good